Hey everyone, today we are talking about Vsepr, or valence shell electron pair repulsion theory. So really that's just another way of saying shapes. Okay, so Vsepr can predict molecular shapes. How does it do that? Well, it's based off the idea that electrons don't like to be near each other, right? They're actually going to push each other away. And so when they do that, when they push each other away, that's going to affect the shape of our molecules. Okay, so the shape is determined by the repulsion of electron pairs. Okay, so let's take a closer look here. So Vsepr theory predicts the shapes of molecules or compounds. We just pronounced it Vsepr, but it's V-S-E-P-R. And again, that depends on electron pair repulsion, right? They're pushing each other away. So we'll get a closer look at what that is exactly. Okay, so with Vsepr theory, we'll be able to predict the shapes of these different Lewis structures we've been drawing. Okay, these are the 5 that you'll need to know, and we're going to go over each one: tetrahedral, trigonal planar, bent, trigonal pyramidal, and linear. So tetrahedral, remember the prefix tetra means 4. So here we have 4 atoms bonded, and what do we mean by that? It's bonded to the central atom here. So 1, 2, 3, 4. And this is a pyramid with a triangular base, essentially. Okay, so methane, CH4, is a good example of a tetrahedral. Okay. Next, if we remove one of those bonds and then we replace it with a lone pair of electrons, that's what we call those, lone pairs, 2 dots, we end up with a trigonal pyramidal shape. So again, these electrons don't like to be near each other, so they're going to kind of push away from each other, and you'll notice that affects the bond angle. Instead of being 109, it's slightly less, 107. And so when you have 3 atoms bonded to a central atom with 1 lone pair, you'll get a trigonal pyramidal shape. So NH3 ammonia is a good example of this. It's similar to a tetrahedral, but you wouldn't be able to see this electron pair here. So again, this is trigonal pyramidal. You'll see this a lot with ammonia, with nitrogen and phosphorus. Next we have trigonal planar. So planar basically means it's flat. It lies flat on a plane. So here we have 3 atoms bonded to a central atom with no lone pairs. So we don't actually have any extra dots. Okay, and the bond angle here is 120 degrees. Again, this is a flat shape, so we'll actually see this a lot with boron. So boron will often form these trigonal planar shapes. Next we have linear, which is pretty straightforward. It's basically a line, 180 degrees. 2 atoms bonded to a central atom. So here we have carbon dioxide, which has a linear shape. It could also just be 2 atoms bonded to each other. For example, 2 chlorines bonded to each other would be linear as well. Okay, so if you just have a single bond, like so, that would be a linear shape as well. So no lone pairs here. And then lastly we have bent. So here we have 2 atoms bonded to a central atom plus 2 lone pairs. And so water is the classic example of a bent molecule. And again, what's happening is that these electrons are pushing away from each other. And that's what causes this shape to be bent. It's also known as V-shape. So you may see that name for it. But here we have, again, 2 lone pairs and 2 atoms bonded to our central atom. That's characteristic of a bent shape. Okay, next we're just going to review the shapes. So here we have 3 bonded, no lone pairs. So this is going to be trigonal planar. Here we have 4 atoms bonded, so remember 4 means tetra, so tetrahedral. This one, you can just tell by the shape itself, it looks bent. All right, so what's missing is you've got lone pairs of electrons over here. Okay, this one we have one lone pair on top and 3 bonded. So this is trigonal pyramidal. And then lastly, a line or linear. This one you can guess. You don't have to know that one. Okay, so what you're going to be doing moving forward is you're going to be drawing the Lewis structures like we've been drawing. And then you're going to predict the shape. So silicon has 4 valence electrons. Each chlorine has 7. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 7. 1, 2, 3, 4, 5, 6, 7. So here we're going to draw our single bonds to connect all of our atoms. And so here we have 4 bonded. And remember, that is characteristic of a tetrahedral. Okay, so refer to the table on your worksheet or refer to these notes to help you with the worksheet.